Hey y'all, this is Sean Victor, and I wanted to make a video on high pressure air regulators, mainly because on YouTube there's not a whole lot of content of people talking about what's inside one of these. I mean, they talk about installing them, maintaining them, putting them on paintball guns, but no one really goes into the inner workings of one of these. Now, that's all fine unless you want to utilize paintball tanks for other purposes. Like in our case, one of the projects that I'm working on is for an RCS thruster, and so this regulator will be super important for providing the source pressure. And so understanding exactly how this thing works, how we can modify it to get better performance, is pretty critical. And so there's a lot of work that I had to do to figure out exactly how this thing's actually working. So what I've done here is I've taken one apart. So this one was off of a tank, but I haven't taken this one apart. But what I'm going to be doing here is I'm going to be showing you one that I've already taken apart, and I'm going to start putting it back together to show you what the innards of this looks like. So this portion without so these right here are known as our burst discs. They're located one on the lower side, which is connected to the bottle pressure. So your bottle pressure is fed into this port. So this whole connection here is what interfaces with your paintball tank. And so you have an access port here for the air to go into, and it travels all the way up into here. Okay, now the portion that I've removed here is the actual regulator portion. So that's the actual brains of the mechanical brains of this device. What's left over here is just really a manifold. So this air goes all the way into here and it taps off at multiple points. So the first tap off here is the high pressure burst disc. Okay, so this is usually there so that you don't damage the bottle or overpressurize the bottle and cause catastrophic failure. And so usually this is rated, in this case this one's rated for 7.5K. You can see that vary depending on the regulator itself. And then you have an upstream one that taps off of the upper chamber area. And so this one's usually at a much lower pressure. In our case, this one's 8.5K. So this one is actually designed to have an output pressure of 160 psi. So if for whatever reason the regulator just decides to, crap the bed and the pressure on the outlet ends up skyrocketing, this will set off. So the way that these burst discs work, I've actually taken one apart. And so what you have here is this thin copper disc here. Okay, if I were to actually put a lot of force here, it would be like me piercing through aluminum foil. Except this is a lot thicker than aluminum foil. And it's specifically at a thickness at which if a pressure were to be focused on the central part here, then it would rupture. Now the burst disc also has a couple of holes all throughout. So there's one hole here and another hole here. That's connected to the opposite side of this disc. So when this disc ruptures, it provides a path for the air to escape through these holes. And that pretty much serves as a way for you to vent all of that excess pressure, and so that you don't have just continuous bottling up of this pressure getting higher and higher and potentially will cause a catastrophic failure event. Okay, so that's their burst discs, and then we just have a pressure gauge here. So it's tapping off of the same port as the high pressure side. So usually it's just there to indicate how full your bottle is. Okay, so this one goes up to 6,000 psi. Okay, so those are our 3 access points. Really pretty simple device. There's not much you can actually do to take it more apart than this. This is really just a full metal body with a bunch of holes drilled in at different points so that you can tap off of different pressure areas. Now if we look at it from the inside, let me get my phone so I could put some more light. So you can see on the inside, you'll see that there is a small little pin opening, okay? And it has a raised surface to it, and that's going to be really important for sealing purposes. So I have a similar device that has a raised surface, just like this. And you can see that it has a hole, but around the hole is a raised portion. Okay, and that is so that you can get a very good seal. So before I go into explaining that some more, we should start talking about the rest of the components. So this, you'll notice, has another thread here, and this allows us to interface with this. This is known as the bonnet, and you can see it screws on just like that. Okay, but before you screw that on, you do have to put some more components in here. So let's talk about the actual mechanical brain of this regulator. So the most critical part is this. This is known as our piston. Okay, the piston is what actually moves up and down within this regulator in order to seal against that inner surface and open and sometimes allow the pressure to come in. And so that's what actually regulates this bottle pressure that we see on the high pressure side and controls whether it comes up to the bonnet side. Okay, so you'll see on here that there's two O-ring grooves. There's one on the lower side and there's one on the higher side. So that'll be the first thing that we put in. Actually, I won't be able to put in the lower one just yet because there is some components that go in here that if I put this in too early, I won't be able to stack those components in. So we can go ahead and put this upper O-ring in first. So this is what the upper O-ring looks like. It looks like it's made out of some hard / like medium firmness plastic. And so, yep, we're just going to put it over there. And I might need to, in this case I didn't need to use some tweezers, but you'll see in the smaller ones I will have to utilize those. Okay, and I'm going to show you after this whole thing's done an actual CAD model that reverse engineered one of these, and we'll look at the cross section to better explain exactly how this works. So really after this point I'm just going to be putting this all together. I'm going to put it all back together, and then you'll have a good idea of the inner guts of one of these. Okay, so after you do that, the next thing we're going to have to put on are these little plates here. This is a plate that makes up what's called a Belleville spring cage. Okay, so this is a piece of metal, but if you look at the piece of metal, it's actually not flat. It has some amount of one concave face and one convex face to it. Okay, so the first one sits, and so actually this surface right here is not flat either. And so this is designed to be put right on top of it. So one concave and one convex surface are right on top of each other. Okay, now the remaining plates stack up. This is why they call it a spring cage. It's because there's actually multiples of these plates. They're all the same, except one. But you'll see that they stack up quite nicely. What you're left with is something like this. Actually, one of them might be backwards. Let me fix that. Oh, yeah, actually, that's right. Okay. So yeah, we have our little spring cage system right there. You can see that well. Okay, and once we have that on, we're going to put our next O-ring on there. I apologize for this being such a long video. I do want to thoroughly explain how this works. Okay, so I've got that O-ring in there. Now I kind of just got to push it and work its way in there. And because this has like a little raised surface lip here, it makes it a little difficult for me to get that O-ring in there, so I'm just gonna give it some. You have to be a little bit careful so you don't accidentally dig into the O-ring and damage the surface, and then it won't even seal that well. But yeah, once you've got it in there, that is what it should look like. Okay, now you'll notice that on the top of this piston there is a little change of materials. It looks like it transitions from brass to what looks like almost like epoxy or something a little softer, a plastic. And this is going to be sealing right up against that raised surface that we saw in here. And so having a material that is that is actually flexible allows it so that that flexible surface can easily sit right on top of a raised surface like that and get a very good seal. Okay, so we got this. And the last part is there's a single little washer. This is actually our first flat washer here. And yeah, that goes right on there. And now we can go ahead and put it in. Just like that. Okay. Last thing is a spring. And so this is actually what, if you look at a pre-assembled one, you notice there's a little pin valve on the very top. And if you put enough force on it, you can actually get it to depress. And you can feel that there's a spring inside of there. And that's the exact same spring that we've put in. So on top of that will go the actual pin valve itself. Okay, so that goes up and down in there. And I'll leave that there for now. But now we can start to assemble the bonnet side. So the only thing left here is that inside the bonnet, do you see this little opening right here? That is an opening for an O-ring to go in. So right here we've got our O-ring, and we're just going to put it in there, and we're going to want to just put an even amount of force on it so that it sits in there and stays in there. Okay. It should look like something like that. Alright, so now that we have that, we are going to get the two sides. We're going to put our pin valve sitting in there, and now we're just going to work to put it on top. Now if you get it, if you're lucky, it should start coming together, but sometimes that pin valve does not align well, and so sometimes it just works better to put the pin valve in first and get it so that it's already in there, and then kind of work the two together like that, and you'll have this. Okay, so you see that pin valve sticking out, I can press it down. The very last thing to do is that there's two little set screws on either side that will hold this together. And so this is what the set screw looks like. Put that in there. You're going to need an Allen wrench, or if you get a screwdriver like this, you can just put it in there. And the next one. Alright, very last thing, there is a set of two O-ring grooves right on the outlet side that prevents a leakage once you make a connection to this CGA port. Okay, let's get two in series, that's good. The very last thing that I wanted to show you is we have the pressure gauge port, we have the two burst discs. The last thing is that there's actually a fill port. And so a fill port usually looks something like this. This is a quick disconnect fitting, and this goes to a 1/8" MPT port. And you'll notice that if you take this off, you'll find something that looks like this. Strange, right? I don't know why you'd have that, but it actually is what prevents the bottle pressure from escaping through this port. And so this little O-ring that's right on the end here is being forced to seal against this surface. And so when I'm putting this back in, you can imagine the bottle pressure is coming in through here, and it's being fed into this port and pressing right up against this surface and sealing that O-ring against the inner surface of this port, preventing the gas from just immediately escaping through the same fill line. And so when you're filling it, you have to fill at a pressure that's higher than the pressure on this side, so that it forces this pin to pop out. Okay, the last thing, you're going to put that in, tighten it in, and voila. Obviously you would want to torque all this down, make sure that everything's good. And I also wouldn't really recommend taking this apart unless you know what you're doing. There could be some safety hazards associated with putting this thing back together incorrectly. So this is really just for an educational purposes, for people to see and understand what's inside one of these things and how it works. So yeah, after this we'll be transitioning. Maybe I'll make a separate video, or I'll just start playing this video showing the CAD model and a breakdown of the innards of how this actually works. Alright, thanks y'all.